Hello viewers, I'm Kausalya. Today we are going to solve problems in exercise 13.1. Problem number 6. A medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. So here you see we are having a capsule which is basically in the shape of a cylinder. So you see this is the part which is in the form of a cylinder. What I had drawn in blue, right? And at the ends we are having two hemispheres, right? So this is one hemisphere and this is other hemisphere. So the length of the entire capsule is 14 mm. So the total length is 14 and the diameter of the capsule is 5 mm. So this is your dia, right? So it is 5 mm. Find its surface area, right? So here we are having two shapes, namely, what are all the shapes here? One is a cylinder and other is a hemisphere, right? So just I am redrawing the given diagram. You see the same diagram, right? I had drawn like this. You see this is the cylinder and here I am having one hemisphere and here I am having other hemisphere, right? So now we have to calculate the surface area. So what is the surface area of the capsule? Just from the observation we can clearly tell that the surface area of the cylinder as well as the surface area of this hemisphere and this hemisphere, right? When you find all these three values and when you add all these things, finally we can easily get the surface area, right? So here you see the diameter of the capsule, right? It is given as 5 mm. So what about the radius? Obviously it is 5 divided by 2, which is 2.5 mm, right? So here the radius of this hemisphere is 2.5 mm, right? Now the next thing is we are going to find the length of the cylinder, right, or height of the cylinder. So how to calculate the height of the cylinder alone? Because here you see the total length is given as 14 mm. So here what we are going to do is again the same thing. You see I am redrawing the diagram. So here the total length is 14 mm, right? The entire length here. So the thing is, you see here the diameter is, it is 5 mm, right? So your diameter is nothing but this is your diameter of the hemisphere, and when diameter is divided by 2 we will be getting our radius, right? This is our radius. Similarly, this is also a radius, right? Because radius is a line that connects the center to any point on the circumference. So again this is also a radius. Similarly for this hemisphere, this is also a radius, right? So what about the value of radius here? So here it is 2.5 mm and similarly in this part it is 2.5 mm, right? So when you subtract this 2.5 and 2.5 from this 14 mm, then automatically we will be getting the length of the cylinder or height of the cylinder, right? So here what is the total length? It is 14. So you see 14 minus, here there is 2.5 and here it is 2.5, right? So you can write either 2.5 plus 2.5, okay? Both holds the same meaning. Or you can write it as 2 into 2.5, right? Anyway, we will be getting the same answer, right? 2.5 plus 2.5 will make 5. Similarly, 2 times of 2.5 will be 5. So here 14 minus 5, which is equal to 9 mm. Therefore, the length of this cylinder or height of this cylinder is, it is 9 mm, right? So next we are going to find the surface area of the capsule. So surface area of the capsule is nothing but, as I previously said, you see here we are having, so only I had mentioned it as 1, 2 and 3, right? So first surface area of the cylinder, right? Curved surface area of cylinder and curved surface area of one hemisphere and curved surface area of other hemisphere, right? So this is what I had written here. So I had mentioned it as 1, 2 and 3 as I mentioned in the diagram. So now just apply the formula, substitute the values, and we will be getting the answers. So here what is the formula for cylinder? It is 2 pi RH. And what is the formula for hemisphere? It is 2 pi r square, and we are having another hemisphere, right? So again 2 pi r square. So now when you add these two parameters, because they are same, right? They are having pi r square, pi r square. So 2 plus 2 will make 4. Therefore 4 pi r square, right? So in these two things, we are going to take the common parameters outside so that we can make our calculation easier. So here I am taking 2 pi r, because here also I am having 2 pi and there is an r. So when you take 2 pi r, here the remaining term will be h, right? And here you see I am just splitting and writing 2 into 2. I can write 4 as 2 into 2, pi into r, right? So here in this case I am taking 2 pi r outside. So 2 pi r is outside. What about the remaining terms? 2 into r. So here I had written as 2r, right? Now just substitute the values. 2 and the value of pi, it is 22 by 7. And what about the value of radius? It is 2.5. And what about the height of the cylinder? It is 9. And again plus 2 into, again what about the radius? It is 2.5, right? You see, regarding radius, I forgot to tell this thing. Okay, when this radius is 2.5, again this line also forms a part of the cylinder, right? Therefore, the radius of the cylinder is also again 2.5. Okay, always keep it in mind. So, you see, that's the reason why here I am taking this r commonly outside and I am substituting the value of r as 2.5. So again, when you solve and simplify, finally we are ending up with the answer as 220 millimeter square, right? Again, this is a surface area, so that's why we are adding a square over here, and the units are given in mm, so only here it is mm, right? We will proceed with our next problem. Problem number 7. A tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meter. Find the area of the canvas used for making the tent. Also find the cost of the canvas of the tent at the rate of rupees 500 per meter square. So, note that the base of the tent will not be covered with canvas, right? So here you see, as we all know, canvas is a decorative thing, right? Which is used on the walls or on the ceiling, as well as on the ceiling, right? So here, what are all the given things? First, you see, we will draw the diagram, right? We are having a tent which is in the shape of a cylinder. We are having a cylinder surmounted by a conical top. So here we are having a cylinder and a cone, right? So how they are? You see, first we are having a cylinder and that cylinder is surmounted by a cone, right? So first draw a cylinder, right? You see, you should draw the cylinder first and it is surmounted by a cone here, right? Next, the given thing is write down the parameters. If the height and diameter of the cylinder, okay, height and diameter of the cylinder are given, it is 2.1 and 4. So here the height is 2.1 and dia is 4. So you see here the height is 2.1 and the diameter is 4. Now the next thing is the slant height of the top is 2.8 meter. So here the slant height is also given, it is 2.8. So find the area of the canvas used for making the tent, right? We have to calculate the area. Then, right, once we calculate the area, then we can calculate the amount required for doing that canvas, right? So here, since we are using the canvas, what are all the things we need to calculate? We have to calculate the total surface area of the tent, right? So here the surface area of the tent is, it is nothing but curved surface area of the cylinder plus curved surface area of the cone, right? So what is the formula here? So it is, you see here, it is 2 pi RH For the cylinder it is 2 pi RH and for cone it is pi RL. So again here you see pi r is common in both these terms. So I am taking pi r outside. So the remaining terms are 2h plus L. Right. So the pi is 22 by 7 and here the value of r, the L is directly given, H everything is given. Right. So the thing is they had given the diameter. Here the diameter is 4. So what about the radius? It is 4 by 2 which is equal to 2. Right. So here the thing is just substitute the values. In the place of r, here just substitute it as 2. Right. So after substituting just solve. Right. So this entire term reduces to 7. Right. So here the answer is it is 44 meters square. Right. So here the cost of canvas is for per meter square it is 500. Right. So totally we are having 44 meters square. Therefore 44 into 500 that gives 22,000 rupees. Right. So here I need to tell you one thing. So here we have used the term, you see I have mentioned total surface area. Right. So whenever total surface area is mentioned, you just listen carefully here. You should cover all the things. Right. So here for a cylinder, you should cover the curved surface area. Right. I believe you people know what is curved surface area is. Right. This area is known as curved surface area. Right. So apart from this curved surface area, you have to include this top as well as this bottom. Right. So that is the meaning of total surface area. But here obviously what we have done, I have considered only the curved surface area of the cylinder. Then I had considered the curved surface area of the cone. So the curved surface area of the cone, this includes both this area as well as this area. Right. So again this problem deals with canvas, right? So canvas is just like a painting, right? It will be done on the walls as well as on the ceilings, okay, to have a good interior look. So you just think by yourself, will we do any canvas at the bottom of a cylinder, at the bottom on the floor? Obviously no. Right. So that is the reason here we have eliminated or we have omitted this area. Okay, the area of the base of the cylinder we have omitted. Then you may ask, what about the top? Right, because on the top there is another portion like this. But obviously here this portion becomes a part of the cone here. Right. So while calculating the curved surface area of the cone, we are calculating this conical part as well as this base part. Right. Or in other words, we can tell that this is common for your cone and this cylinder. So that is the reason here why I had written it as curved surface area of the cylinder, because this curved surface area of the cylinder, this covers this area. Right. And again the curved surface area of the cone, this covers this entire area. Right. So finally we have calculated the total area and as well as we have calculated the amount we need for the canvas. Right. So this is the final answer. Right. So here we come up with 22,000 rupees. Right. So that's all. If you have any doubt, let me know in the comment section. Thank you.